Hey guys, this is VesselSense, and just want to go ahead and do a demo of a computer that I will be installing next week, and just kind of describe what it is and do a comparison against a regular computer so you kind of understand the reason this particular type of computer exists, and so we can kind of compare. So why this computer instead of something like a Mac Mini or a laptop or a regular desktop computer? The primary reason is because these computers run very, very low power. They also run what's called headless, which means that there's no actual operating system user interface for you to kind of click through like a regular Mac OS or Windows. For the most part, everything is operated in terms of the software via their web browser. And so that only means that you need an HTTP connection and a web browser to connect to this computer and interact with it. So just to describe the build and kind of go into details here, there are only two plugs on the outside and they are waterproof. First one is the NMEA 2000 plug. So this allows you to connect to your NMEA 2000 network via a standard drop cable. And then a 12-volt pigtail, and this just has a couple of connectors so that you can connect to your 12-volt power supply. Typically a house battery or a start battery for your engine. Now, in terms of the computer's enclosure, it's just a standard junction box. It's an electrical junction box. These are very common. Mine, the one I purchased, happens to be on Amazon.com, so very straightforward getting these. And then inside, I just have a Hat Labs introduction. This is what goes shipped for the first component that I'm going to describe, which is called the sailor hat. And the sailor hat is, hats are these kind of pieces that stack on top of one another on top of the Raspberry Pi computer. There are 3 capacitors and there are plugs for the actual 12-volt power supply. This is a input for 12 volts and an output of 5 volts. So this can actually power other 5-volt components in addition to receiving power. There are also capacitors here for basically providing power so that if there's a loss of power from the 12-volt side, this particular device is designed to maintain power and then signal shut down to the computer. And then once the computer has fully shut down, gone through the shutdown process, then it will actually power off completely. The second piece here that you can't see underneath is called a Waveshare can hat. You can kind of see it from this angle. You can see these, the second stack here. And you can see the green, blue, and white cables that are coming from this actual adapter here. The can hat is what is actually allowing NMEA 2000 to connect to the computer. And then, so it's both input and output. In the event that you have something that you want to send out to the NMEA 2000 bus, it would be received into the Raspberry Pi computer and then put out that way. The actual computer itself is a Raspberry Pi 4B unit. The reason I chose 4B is because it is a very low power in comparison to the newest unit, the 5. 5 tends to take more power in order to run. It has more capabilities in terms of its processor, but for the most part, what we're using this particular computer for is to run SignalK and a couple of other apps like InfluxDB and Grafana, so that we can basically store data that comes in through different networks and then provide visualizations for that. For example, dashboards, things like that. The last piece is this external Bluetooth dongle. The reason I use a Bluetooth dongle instead of the built-in Bluetooth is because it's way more reliable. Bluetooth can be a little bit challenging to get reliable connection from the internal built-in Bluetooth piece, so we basically use an external to connect to devices that are communicate over Bluetooth. In our particular case, we're using this for Victron components, things like solar charge controllers or inverters or DC to DC converters, things like that. So we use Bluetooth to communicate with those. Otherwise, we'd have to use VE direct, which would require multiple USB ports, USB cables, and also glands on the outside of the box to receive each of those components. So a lot less complex in that regard. Anyway, in terms of the computer itself, the reason we choose this type of computer is because it's way lower power draw, and it can run in an always-on state, which is very nice. That means that it's always collecting whatever data is being broadcast, whether that's from your solar charge controller, your battery monitor, your NMEA 2000 network, or any other device that's communicating to this particular computer. And then we're using SignalK to centralize all of that data and then push that back out to other clients being things like Grafana or the built-in web apps for SignalK like Kip, or even mobile apps like Wilhelm SK. So anyway, that's it for my demo. Appreciate you watching and take care.